What I learned, though, was that the Shewhart cycle needed to have prediction built into it, which makes it live right inside the theory of knowledge. So we needed to make predictions in our plan. Planning requires prediction. Prediction requires a theory. In fact, that became my new mantra. Planning requires prediction. Prediction requires a theory. So we really worked hard at that. And then here's another example where I think the Shewhart cycle is getting closer to the form we have it now. And this was at a 4-day seminar, and he says, Ron, I'd appreciate your help on the Shewhart cycle. I will explain it at 9 o'clock, then you run through it in your own way. Is that good? So there was a chance to pilot among 600 people. You know, first he gave it, and I gave it. So I learned a lot from that. And so it really became the PDSA, the Plan, Do, Study, Act, which, again, tied in with the planning part and the study part had to be connected, deductive, inductive. So this really made it live in the theory of knowledge. Now, Deming's version didn't really go this explicit, but we thought it was important. We've been doing it ever since, that in the planning you make your predictions based on your plan, and then when you get to the study, you determine whether or not your predictions come true. You compare the data to the predictions. That's how you learn. That's right out of theory of knowledge. In 1990, I sent him the first 5 chapters of the book. So 82 to 90. Took me that long. First 5 chapters. He says, I don't recall the content of your book, which I'm delighted that it's in its final stages. But here's his warning. If it speaks of the PDSA, be sure and call it the PDSA and not that corruption PDCA. Whoa. Fortunately, I didn't have PDCA. So there's a big misunderstanding about PDCA. Now, then he took the 5 chapters and he wrote a foreword. And this is the foreword. I don't know if you can read it, but I do have a copy at the end of the morning session. You can pick up your copy. This became my North Star to write the book. This became my North Star. And I've sort of highlighted the idea of prediction in there. And even though my book probably wasn't close to this that he read, this was the North Star. The problem of prediction. And then the answer is predict whether one of the methods or materials tested will in the future, under a specified range of conditions, perform better than the other. Prediction is the problem. And then later on in that next paragraph, significance or the lack of it provides no degree of belief, high, moderate, or low, about prediction of performance in the future, which is the only reason to carry out comparison of tests and so on. So again, if you think of the pond, you can really estimate what's in the pond. So the major source of uncertainty is sampling error. But the major source of uncertainty in a prediction in the future is just that. It cannot be quantified. You cannot quantify it. So how could you write a book, statistics book, that would cover that? So this became my North Star, and it haunts me ever to today. So at the same time I was doing this, Deming was working on a system of profound knowledge. And of course, Mike Twitty talked about that in Deming 101 yesterday morning. The evolution of the system of profound knowledge. And this is a paper that he used for his North Star, well, it's his working paper, I should say. And it's called Foundation for Management of Quality in the Western World. This was handed out at the 4-day seminars. This was before the New Economics was out. And I highlighted at the very bottom of that, that was presented at Osaka in July of 1989, and noticed in red, comments and help appreciated. Comments and help appreciated. Well, there was help, and actually it was from University of Minnesota. 3 authors took that paper, and they sort of put it together into their kind of exploring what that was really saying. This was on May 21, 22, 1990. They listed what Deming was calling profound knowledge, and you see these listed here, A, B, C, D, E, F, G. He just made this big list. It was actually more than 14 points now. It was really all these different principles or elements. And so I use those elements to write the book. knowledge about statistical concepts of variation, knowledge about losses from tampering, knowledge of procedures aimed at minimum net or economic loss, basically Schuhart's concept, knowledge about interaction of forces. I needed something about testing interactions. Plant experimentation did that. Taguchi loss function. We heard from Bill Bellows yesterday, the Taguchi loss function. It was loss to society. When I studied the Taguchi book, when I saw Loss to Society, his next sentence in that book was that the actions you take if there's a loss to society, if you fail to reach the target or move towards a target, the loss is greater than the actions of a thief. I'll never forget that. It's a loss to society. A thief there's not loss to society. I take your money. That's not loss to society. There's still the money. This was worse than that, loss to society. Of course, when everybody looked at the Taguchi loss function, they put the loss to the customer there. It was society. Very important. So this was my checklist that I used to write the book that I thought was really important. That's the first part. And then knowledge about theory of extreme values, knowledge about statistical theory of failure. And so I really needed to bring a lot of Taguchi ideas in here as well, especially robust design. Almost 2/3 of the ideas were around that. Well, this paper then from University of Minnesota, Deming was not at that conference, I was, but they put together then, they said this is, if you really look at this, these go in 4 buckets. These go in 4 buckets. So these are the buckets they ended up with. This is 1990. Cognitive psychology, organizational theory and behavior, statistical theory, and systems theory. Okay? All of them fit underneath those 4 buckets. Well, within 3 months, in September 1990, guess what Deming did? He's a fast learner. Look at page 11. He now has 4 buckets. Not the same ones as the University of Minnesota, but and I did not talk to him about this, but I'm convinced that this triggered him to really put it together. We've got to look at it in a broader context and then put ideas around it. So here are his 4 points. So I would say he was a fast learner. He listened to the response and comments. So his book really became the New Economics 3 years later. So 6 years later, now I'm ready to publish the first book. So there it is, 1991. So that was an attempt to do this, and actually it had quite a few good things in it. I had control charts at the very beginning, which I thought was important. I talked about the enumerative and analytic studies. I went all the way back to Sir Ronald Fisher, et cetera, et cetera. But his book came out in 93, and there it is, which, by the way, the second edition came out after he died. We took Seal's notes and did the second edition, put all the notes from the last 6 months of his life and put it in the second edition. And then it took 6 more years before I wrote the second edition. So now the feedback was, why in the world can you have experimental design and have control charts in the beginning? So we put them at the end. We put them in appendix. So we changed that, which I think was a mistake. But we did do one good thing about enumerative and analytic. We changed it from sort of a dichotomy for classifying problems in enumerative and analytic into more of a continuum. So the left-hand column is the continuum, with the top being estimation, at the bottom being prediction. The next 2 columns represent then the statistical knowledge required and then subject matter knowledge required. And if you look at those 2 columns and look at the examples there, starting with acceptance sampling, census, and so on, down through prototyping and so on, you'll see that at the top, statistics plays a major role. But soon it dies out, and all you can do is use statistics to support the learning of subject matter knowledge. That was a breakthrough in the book. So we were always trying to use statistics to enhance the subject matter knowledge. That was the key. I think we're getting closer. So it took a few more years, but in 2012, which again is 9 more years, we published the book, and McGraw-Hill wanted it published in 2011, but Tom Lloyd and I said, we're not going to go with the numerical goal. We're going to wait till we have it we think is pretty good. So it came a year later in 2012. So this is where we're at as of June. And of course, now I'm working on my next version of this book because we still haven't reached it. We still have the North Star, which you'll see a copy of, the foreword. We put the foreword in every one because that's really where we're headed. We don't know exactly what it's going to contain, but back in 1990, Dr. Deming said this book should be called Sequential Experimentation for Quality. It never got to that, but the next edition will be called that. So we're still working on it. So that's kind of my story of writing a book for Dr. Deming.